Hello and welcome to another video on my channel. In this video I am going to continue our discussion on operator overloading in Java. And if you recall, we created a vector 2D object and overloaded the plus, minus, multiplication operators, also the negation, okay? And I mentioned that whenever we write vector 2D v3 equals v1 minus v2, which v1 and v2 are also types of vector 2D. This is just a convenient way for us to write the code, right? But what happens actually behind the scenes is that the compiler replaces this with v1 minus v2 with v1 dot subtract v2, okay? So compiler goes and looks into the first object and see the type of the object implements the subtract method or not. And if it does, it just replaces the v1 minus v2 syntax with v1 dot subtract v2, okay? Now, I told you that this happens behind the scenes, and the compiler does this and then generates the bytecode for this, for v1 dot subtract v2, okay? Now in this, now I'm going to actually prove it to you. So if in the Eclipse, if you go and look at the bytecode of these two lines, okay? So remember, bytecode is what is generated by the compiler and what is going to be executed by the JVM, right? So that's what actually matters, okay? Now this code is at line 12. And this code v3 equals v1 dot subtract v2 is at line 15, okay? And then for this code we get this bytecode. So it's at line 12, a load 1, so load the first object, the first object reference, okay? These are just bytecode instructions for the virtual machine, okay? A load 2, load the second object reference, invoke virtual. So invoke virtual is basically telling the JVM run a method in an object, okay? So it's a virtual object, or it's basically a method. And what is that method? Demo._opov, this was our project name, vector2d.subtract. So this is what's actually happening. When you write this in the bytecode, it tells the JVM go into the v1 or go into the vector 2d, which is the type of the first object, and invoke the subtract method. And in this parentheses, it specifies the type of the argument or parameter for the subtract method, which is vector 2d, right? And then the return type is also vector 2d, okay? So the bytecode for this v1 minus v2 equals v3 is basically invoking the method subtract in v1, passing v2, and then returning the result, okay? And this kind of bytecode, invoke virtual, with the type, the method name, the parameter types, and the return type, is called method descriptor in the bytecode, okay? So this one, so for the second line, which is v1 dot subtract v2, this is the method way of writing the subtract. It's exactly the same. So a load 1, load the first reference object v1, a load 2, invoke virtual, vector 2d dot subtract. The input argument is vector 2d, and the return type is also vector 2d. So you see, this is the two bytecodes for this line and this line are exactly the same. That's why this method operator overloading works. And this was an extension to the Eclipse compiler. We enabled the Eclipse compiler to recognize this kind of convenient way of writing the code, and then replacing them in the bytecode with the actual method way of doing the subtraction between objects, okay? Now what I like to do is go back to the first slide when we started this discussion on operator overloading, and discuss again what happens with the auto boxing, okay? So I told you, when you write the object double x equals 2.3, what happens behind the scenes in the bytecode is this line of code. So the bytecode is replaced, the right hand side is replaced by the value of which is a simple factoring method, a static method in the double object. Okay, and for example, if you write double y equals x was a double object, then the compiler replaces this with something like this, right? The object double x replaced by calling a method in the object class, which is double value, and the other examples. Now I'm actually going to show you in Eclipse. So let's head to Eclipse. First look at the bytecode for these 2 lines of code, and then go and check what happens behind the scenes for auto unboxing and auto boxing in Java. So this is our Eclipse. In the demo operator overloading, if you recall, we wrote a class test vector 2D, and here we have the lines. Okay, now if you want to see the bytecodes in Eclipse, you have to go to the show view, and there is another view called bytecode. So this is the actual bytecode. Okay, and let me see if I can increase the font size. I'm not sure if it's possible, but I hope this is clear enough. Okay, so what happens here? So how many lines of code we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 lines of code, and we have 9 blocks of bytecodes generated for each line. Okay, so in the first line, this L0, it's line 6, and in this line of code, we're just creating a new object of type vector 2D with input arguments are numbers 0 and 1. So what happens here? So it says in line number 6, create a new object vector 2D, and push it into the stack. And then the parameters are some double, which is a constant number. It's a number 0 and number 1. Okay, so the parameters of the constructor are just 2 numbers. And invoke special. Invoke special means basically the constructor, or basically initializing. Basically it says initialize the object with these 2 numbers, which is basically run the constructor. And the constructor takes the input parameters to the constructor. In these parameters are 2 numbers of type double, and v means void. So this special method, which is the init method or constructor, doesn't return anything, and we know that this is true. Constructors in Java don't return anything. The return type is always void. Okay, exactly the same thing for the second object. And finally, after running the initialization, it says store it in the stack or in the heap. Okay, now you can come here and see what is the type of local variables that have been stored, right? v1, v2, v3, they all have the types of vector 2D, and they were used between these lines, right? And these are the reference numbers to the objects. 1 is v1, 2 is v2, and 3 is v3. And that's why it says a store 1. So 1 refers to v1, a store 2 returns to v2. Okay, so the same thing for v2. At line 7, we're invoking new object and pushing it up to the stack. So if you look at d-up, duplicate top single word item on the stack, d constant, push the double 0 or 1, ldc, push single word constant onto the stack 2. So 0 and 1, apparently they have they're defined as constants in the bytecode, 0 or 1. But other double values, they use the bytecode instruction ldc, push single word constant onto the stack 2. And invoke special is basically run the constructor or initialize. The inputs to the constructor are double, and the return type of the constructor is void. Okay, and then store it as number 2. And then we're printing the value of v1. And again, remember, we overrode the toString method, and this is not part of the operator overloading. This is built in Java. when you pass in an object, by default the compiler substitute this, replaces this with the call on the toString method, and you can see this on line 9. It says get a static, which means go and get a static method. Get a static, get value of the static field. So static field is basically system.out. We know that the out is a static field of type print stream, as mentioned here. It's in the Java IO print stream. It's in the Java IO package, and the type of this out, this static field, is print stream. Okay, and then it says a load 1. Remember, a load is just load the object reference. Okay, 1, if you recall, 1 was the v1. It stores in the heap as reference 1. A load 1, so it loads v1, the object reference for v1. And now what happens when it invokes print line? So invoke virtual, which means run a method. Which method? Print line. And the type is object. Okay, v. And the same. So it knows this, and then the JVM knows it has to basically run the toString method on this. Okay, and same thing for the next line when we're printing v2 to the console. And the next line is basically where we define the v1, the subtraction, via the math operator minus, and it loads v1, loads v2, and then invokes a method. That's very interesting. We write v1 minus v2, and it invokes a method. Invoke virtual means invoke a method. And what method? It's vector2d.subtract. So it goes and calls the method, and the parameter type of this method, the input parameter, is vector2d, and the return type is also vector2d. And I told you basically compiler replaces that with this code. So these two codes right now are equivalent, and that's because their bytecode is exactly equivalent. Okay, now here, for example, this line, so we also implemented the negate function. So when I say minus v1, remember v1 is object reference. So what happens here? It loads v1, a load 1, and invoke virtual. So first it runs a method on the vector2d. And what is that method? It's negate, right? So when compiler sees this minus object v1, it goes into the object v1, which is vector2d, and see if there is a method called negate. And if it is, it just invokes that. And I told you that's why these two ways of writing minus v1, v1.negate, they're exactly the same because their bytecodes are the same. So it invokes virtual a method called negate, and it doesn't take any parameter type, it's void, and the return type is vector2d. And finally it invokes virtual print line. The input type is an object, and the return type is void. Okay, and exactly for the same, the next line, load v1, invoke a method vector.negate, no input parameters, the return type is vector2d, and then invoke print line method, and the input type is an object, and the return type is void. Okay, and finally it says okay, return. There is nothing, no other code to be executed. And the local variables are args. Okay, one arg here, v1, v2, v3. Args are stored at number reference address 0. v1 is address 1, v2 is address 3, and v3 is address 3. Okay, and v3 is only used from L5 to L10. These blocks from L5 to L10. v2 is used from L2 to L10. Okay, and v1 is used from L1 to L10. Okay, Alright, so this was the bytecode for this. But now let's check the auto boxing and unboxing, which is by default allowed in Java for the wrapper type classes. So let's create another class, test auto boxing, and I am going to create a main. Okay, so right now we don't have any bytecode in this class. Now let's write a double x equals 2.3. So in the bytecode, we have a main method. At line 6, we have something to be executed. LDC, push the single word constant onto the stack. What is the value? Is 2.3. D store. Remember, for objects, it's A store, which means save a reference. D store, it means just store a number of type double. Store double in local variable. So we have a local variable. The first one is always args in the main method and stored in the address 0, and local variable x of type double, and happens or is used between L1 and L2 blocks, or from L1 to L2, and is stored at on the stack at the reference address 1. Okay, so it's a type double, it's not the object reference. Alright, now let's create double y equals 2.3. Now let's see what happens here. Alright, so for this primitive x equals 2.3, there was nothing special. The bytecode was exactly what we expect them to be. Create a number, push it to the stack, and store the variable. But now for this object type class, we have a primitive on this on the right side and object on the left. So what happens here? On the line 7, it has it stores the 2.3 parameter onto the stack, but then invokes a static. Invoke static means run a static method. For the instance method, it uses invoke virtual. For static methods, it uses invoke static, right? And what is this static method? You can probably guess. Value of. So double dot value of. So basically compiler does this. Compiler does this. Double y equals double dot value of 2.3. Because I have already declared y, I just write y. Or maybe let's call it another variable. Double y1. Okay? So bytecode for this one equals immediately to a primitive. It invokes the value of method, and the input type is a double number, and the return type is a double object, and it stores it as an object reference, a store. It pushes a store object reference in local variable 3. Okay, and now exactly the same bytecode happens for this code. So in this code, line 9, we save or push the value of 2.3 to the stack, and then we invoke a static method value of with the input type of double and return type of double object. Okay, so this line of code and this line of code have the same bytecode, therefore they are executed exactly in the same way with JVM. Okay, now let's call this case 1. This was auto boxing. Now let's look at auto unboxing. Auto unboxing. In auto unboxing, now we have this y, and let's call double z a primitive type assigned to a object. Let's see what happens here. And this is exactly what I told. So it says on line 13, load is load an object reference. What was the object reference? 3. So what was 3? 3 is y, variable, local variable y. Okay, and then it actually runs a method, invoke virtual, run an instance method. What is that instance method? Double dot double value. no input parameter, the return type is double. So basically compiler behind the scenes, compiler does this. Double, let's call it another variable z1 equals basically y dot double value. So compiler does exactly this. See the bytecode for this line, load the variable, invoke the method double value is exactly the same as the next one. Okay, so auto boxing and unboxing. So now we have two objects y and y1. Okay, now let's say I call double w equals 2y, a double number times y. Now what do you expect to happen? Y is an object, so the compiler first has to unbox it and call the double value method on it. Okay, and then does the calculation, and then next it needs to box it again to assign it to a double object. So let's look at the bytecode. On line 18 we have the the constant value of double value of 2. We have to load a object reference 3, and 3 was basically y, and then invoke virtual. What method are we invoking? Double value, no input parameter, the return type is double. So now it's doing the auto unboxing on the y, and then demul, which is just multiply two doubles. And then what should happen next? As we expect, it has to do a boxing. So invoke a static. What static method? It's double dot value of, and the input type of this value of is double, and the return type is a double object, and it stores it in the stores the object reference to the address 9, reference address 9. And if you look at the 9 is the local variable w of type object double. Okay, so we have 4 stack, 10 locals. Okay, so what happens to the what does compiler do? Compiler does this behind the scenes. Okay, compiler basically double, let's call another variable, happens this double dot value of 2 times y dot double value. So compiler does this, but because the compiler has this nice auto unboxing and auto boxing feature, instead of writing this chaining of methods, for us it's just a convenient way for us to write this 2 times y, even if y is the object of type double. Okay, but what happens in the bytecode is this one. I really want you to understand this, because then it becomes very clear how we included this operator overloading extension for Eclipse compiler and how it actually works. What are we doing with this? Okay, now the final example is right now we saw the operation between a number and an object. Let's have again another example of auto boxing and unboxing, but this time let's double for example a equals y plus y1. So we have two objects of type double with the math operator plus and assign it to another object, and you probably can guess what happens here. So we have to first do 2 auto unboxing, because so the compiler only knows how to apply the plus operator on 2 primitives. So it does the auto for example auto unboxing first to get the double values of these numbers, and then it has to do the summation and do auto boxing again. So load reference object 3, object 3 is y, and invoke a method. What is that method on y? Is double value with no input parameter and return type of double, and load the object reference 4 was y1, and invoke virtual. What was that method? That method was double value and then it returns type is double. So it gets the double value, and then adds 2 doubles, and then invoke static. Why is it invoking a static method? Because now it has the basically the result of this summation, which is a double number, but it has to convert it back to a double object. So it uses the simple factory value of in the double class with the input parameter of type double and return type of double object. Okay, so what happens behind the scenes? So basically compiler does this: double a, let's call it a1 equals double value of y dot double value plus y1 dot double value. What happens behind the scenes is this one, but then it's just a more convenient way for us to write it in this way. But eventually compiler does this, and this is what the actual bytecode that is being generated for this line is actually this one. Okay, I hope you understand this, and I hope this is clear enough. Thank you for watching, and I'll see you in the next video.